folks, my name is Cian Clarke, and I work for a company called Nearform. We're a company headquartered in the southeast of Ireland, which is where I'm from, but we have a kind of a global presence of folk all around the world in the US, Canada, Italy, Ireland, the UK, Eastern Europe. And we sort of came of age in the era of Node.js as like the back-end language of choice for folk and event-driven programming and so on. And that's sort of been our bread and butter for the first kind of decade of the existence of the company. But of late, we've been kind of looking at one another and thinking, like, what's the next 10 years going to look like for us? And where can we really put our mark? And something that's really interested us has been this world of AI native engineering. And what could we do to lean into a really progressive methodology of build, using things like specs to move much quicker. So I wanted to give a little bit of a background as to what our experience has been in the last 6 to 9 months in this world. Starting out with the how we got here slide, then talking a little bit about how it's compared to our world of vibe coding, and how why we like specs so much. We're going to talk a little bit about unicorns, but we're not going to talk about technology company unicorns with billion-dollar valuations. We are literally talking about four-legged horse-like creatures from the fantasy world. We're going to have a good time. Then we're going to talk about how we do spec-driven at Nearform, a little bit of lessons learned, and some resources I found really useful as well. I'm on LinkedIn. I'd love to say I'm on all the things, but I'm really just on LinkedIn these days, posting about all of this stuff. Feel free to give me a follow. And so as we think about this kind of journey, right, coming from AI-assisted all the way up to this kind of agentic delivery at scale, I like to think of companies enabling the likes of Copilot, box ticked, right? We're doing AI native engineering. Like, it doesn't really work out that way, right? So the line-by-line level assist is not bringing these mass productivity gains. People take it a step further and they start doing things with agents and spanning multiple files, right? And that does bring some measurable gains. But I think it has a real ceiling to what you can accomplish with this sort of AI augmented workflow using agent mode. And unless you can bring in some new techniques and frameworks, you're going to run into issues eventually and hit a ceiling of what the models can achieve. Then we come to spec-driven development. In my eyes, that's kind of the state of the art right now. That's where I'm spending a lot of time. And I do think the gains here are quite measurable. I think it tends to remove that ceiling of what you can accomplish with AI models. And then if we look across the horizon to what's soon to come, so how do we scale this up across multiple teams? And Guy in his keynote talked about this transition from single player to multiplayer. I love that. That's a great way to look at this. How do we all collaborate across multiple teams, delivering things using specs and agents, rather than just running through a bunch of tasks as a lone contributor? That's sort of where I see what's next, where I see a lot of the challenges. And from a lot of the presentations this morning, it sounds like most folks are in violent agreement. This is a thing we would love to see more progress on. If we look back across the last 3 years, it's hard to believe that Copilot's been around since June 2022. That's pretty wild to me. But another couple of kind of key things that have happened along the way. February of this year, we saw the term vibe coding get coined. So we're really, really recent. Like, what's that? 10 months ago at most. Another couple of kind of things that felt momentous. Cursor releasing their 1.0 release in June. And then again, like only 2 weeks ago or so, their 2.0 release coming out. And in the meantime as well, AWS releasing Kiro. Some great sessions here today on Kiro. Probably the first IDE in my eyes to really codify a lot of the techniques of spec-driven development into an interface, something I've really loved to see. But this really condensed timeline in the last 9 months, what's going on? There's something in the water, right? So it's been great. I wanted to talk about what a traditional vibe coding flow looks like, while acknowledging the irony of using the term traditional in a term that's been around since February. But such are the rules of the world we live in these days. And before talking about this, I actually wanted to jump to a live demo, and I'm going to use Kiro in vibe coding mode for today's demo. Can everybody see that okay? And what I'm going to ask for is I want to build a 3D rendering engine to render unicorns. I did promise you unicorns, in varying configurations in browser. And we're just going to send it on its merry way, because there is nothing like combining the demo god's anger for a live demo in the first place with the non-deterministic output of models, right? So we're going to have a good time or a really bad time. I'm not really sure. Let's see how this goes. So we'll let the model go about its merry way. And what typically happens here, right, is we try to one-shot prompt what it is we want to build. And eventually that technique yields, a technique that doesn't really scale over time. So I want to build a unicorn rendering engine. The model goes and does some work. Then I realize, actually, I forgot a requirement. I'd like to make the color of the unicorn's mane customizable. Then I realize that it's building it in Vue.js, and I don't know Vue.js. I know React. So I'd like to retool. Could you please build this in React instead? Then I realized the model actually didn't complete one of those requirements I asked for earlier. So it put in a stub for changing the color of the unicorn's mane, but it didn't actually complete that feature. Then the model gets stuck, starts iterating. And what does a model do in vibe coding mode when it gets stuck? Every single time, I swear to God, time to retool the test runner. So it uses Jest for running its tests. It's going to retool to like the Node native test runner or something. Doesn't fix the problem at hand, but it loves making busy work for itself, right? Then along the way, the model added a feature I didn't ask for. I'm asking it to back out that change because I didn't really want that feature right now. And then all of a sudden, I'm out of tokens. So let's see what Kiro's been up to in vibe mode. OK, looks like it's built something. Let's see how it looks. stdt. OK. I mean, not terrible, but like not really a unicorn. Kind of looks like one of those sausage dogs, right? It's OK. I did have one I prepared earlier as well. This is like the best part of this demo, right? Like non-deterministic outputs. I don't actually know what the model is going to give me. Sometimes it comes out upside down. Sometimes it's lost a leg through a tragic accident. It's a lot of fun. Here's another example of what it produced previously. That to me is a rhinoceros. That's not a unicorn. But it is fun to see what comes up. So if we were to approach that problem with specs, right, how would it look a little bit differently? And I think with specs, right, much like with engineers, we tend to do a lot better when we kind of force ourselves to decompose the problem, articulate the why behind what we're trying to accomplish, and then use that context when we go to build something, right? And it turns out models appreciate that same kind of methodology. And so we might say, hey, can you help me draft a PRD for a unicorn building rendering engine? Stranger things have happened. It outputs a PRD. We review the requirements that the model has generated. We might then decide to add some very specific descriptions on how it is you would go about drawing a unicorn, and I'll show this in a second. Then we would ask the model to generate a tech spec, an architecture design document. It's going to codify in that architecture document. I actually want to build this in React and not in Vue. Please use React. That saved me that earlier problem. By virtue of having a PRD, we've been forced to think about the requirements. Where it's hallucinated a bunch of requirements that we don't really need. We can nuke those out of the PRD, and now they're no longer going to be built. We just have so much more control over how we steer the outputs of the model. It does take a lot longer, like a lot longer, but the results are unquestionably orders of magnitude better. And so we've got a product requirements document, we've got a tech spec, we've got the what and the why, and we've got the how in our tech spec. Now we're going to ask the model to generate a backlog. So decompose our list of requirements plus our tech spec into a series of tasks that we're going to go after one by one in separate context windows, and we'll talk about this more in a second, in order to yield better results. Then our developer begins working on task 1, then task 2, then task 3, with a very tightly honed context window relevant to that very task, allowing the model to have much better results. I'm going to show you what this looks like in Kiro. Let's jump to better unicorns. And so, not sponsored by Kiro, by the way, just like the two. And in here, we've got a requirements doc. And in here, I put in a very specific piece of context about looks like a unicorn. And here's that kind of key differentiator, right? So defining what a unicorn is to the model, and then forcing it to think like Minecraft-like visuals and primitives available within Three.js, and don't get too ambitious, right? The reality is, with a vibe-coded model building something in Three.js, we're not going to be able to make a really, really detailed unicorn. It's not going to look amazing, so let's embrace it and build something a little more lo-fi. There's a bunch more in the specs here about requirements for configuring and so on. That requirements document resulted in an architecture document, which I actually didn't make any real changes to, sort of agreed with the base foundations of it. Quite detailed for a fairly basic unicorn rendering engine. And then it's decomposed that into a task backlog, and each of those tasks has just enough context for the model to be able to complete the task at hand and be successful. So a much better bounded use of context, and we'll talk about that again in a second as well. I'm going to show what it built. Here is a spec-driven unicorn. Not perfect, but I would say that is a much more plausible unicorn, right? It's got a mane. I can change the color of the mane. Kind of comes in rainbows, which is nice as a default. Change the color of the body, and so on. So, much better than whatever this poor miscreant is. Okay. So what is it that's happening along the way that's caused this methodology to perform so much better, right? So we have this sort of predictability of outputs in what we're doing. And by virtue of being grounded in the specs, the model is producing a much more deterministic output on our behalf. There's fewer wasted cycles along the way, trying to retool, trying to add features, remove features, and so on. And it's also solved for both the over-eagerness problem, that problem of doing things that I didn't even ask for, and also the under-completeness problem of not actually completing requirements I asked for. Two different ends of the spectrum, right? Over-eagerness versus under-completeness, but both equally as much a problem with that sort of traditional vibe coding methodology. So by virtue of having our PRD define our requirements and our architecture design, grounding the model in how to build things, and then decomposing those tasks into a backlog, I think that's really the crux of solving for that over-completeness or indeed under-completeness by giving the model a much better unit of work in the form of those individual tasks that it's completing. The other thing we've done a much better job at doing is a much better bounded context window along the way. So by combining the PRD, that what, and a little bit of the why, with the architecture document, the how we're going to build it, that makes for a decomposed backlog of things to do for the model that have just the right amount of information in order to complete their task. Last but not least, by grounding the model in that architecture document, we're no longer seeing quite as many arbitrary retooling cycles. So trying to retool from the Jest test runner to something else, right? It's just busy work for the model. If we're specifying in our architecture document, this is the version of a tool we want to use, we're less likely to get that type of behavior. I wanted to talk now about some of the building blocks of spec-driven development and how we've been doing spec-driven and Nearform. First, starting with the framework that we use. So we'll often use Kiro for building. The other thing that we use a lot is a tool set called the BMAD method. And we're working on incorporating into the BMAD method some of our own roles as Nearform. So people who we have in Nearform being represented by a very hyper-specialized role definition with a series of commands in each role. I saw in one of the earlier talks, people talking about this idea of specialized roles rather than generalist full-stack engineering roles as a direction of travel for a lot of agentic development tools, and I think that's something that holds a lot of promise. So we've codified what it means to be a technical director, or a QA tester, or a back-end engineer, and so on. We've also built a series of templates for what we think a good PRD looks like, what we think a good architecture document looks like, and so on. So that forms this sort of framework that we ship with each of our projects that we're delivering in a spec-driven manner. Then if we look at the project level specs, the things that live within the project itself, we have the PRD we talked about earlier, the requirements doc, so the what or the why. We have the architecture doc, or the design.md as it's called in Kiro, which is talking about how we're going to build this. We have the project constitution, as it's called in SpecKit, or I suppose you could view this as synonymous with the ClaudeMD file or a cursor rules file, but essentially here's a series of golden rules for how we build software in this project that I do not want you as a model to break. Annoyingly, it's called a different thing in every single IDE, and it'd be great if we could all centralize on what we're going to call this, but we'll get there. Last but not least, then we have that backlog, the decomposed list of tasks that we're going to go after. And within that backlog, we end up with a series of specs per story. So each task gets its own little bit of context. We like to write a work log, have the agent write a work log to that story spec describing what they've done in the present task And that means the n+1th, or the next task, is able to look at what was done previously and use that as context in how to now go about implementing its feature, because very, 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 very often, that previous story is going to dictate what the model is going to do next. Last but not least, we like to rely on a lot of models in the open source ecosystem, a lot of modules rather, sorry. And very often as we discover we're relying on, let's say, the very latest cutting edge version of a module that the foundation model has no knowledge of. And so usage specs, with, of course, our good friends in TESOL, massively helping out in teaching the model how to use something like the latest version of Fastify, or how to use even a very old module that might not have critical mass within the foundation model itself, so to prevent those hallucinations from happening along the way. Now, this is all well and good within a lone contributor, or actually I really like the term from Guy's keynote, single player versus multiplayer. Maybe I'm going to steal that term. But the idea of most of the tools for doing spec-driven development right now being centered around that single player mode of operation is probably the biggest challenge that we're having right now. And so that's something we're having to work to overcome. Here's kind of the rough plan on how that's going to go, and it's showing great promise, but I don't have all the answers just quite yet. So first and foremost, the tools are built with the assumption that you have a lone contributor, an individual contributor, driving all of the stories that have been decomposed in series, one by one, right? That's not great where we're building out a team of engineers that might be much smaller than a traditional team. We're no longer having teams of 12 or 15 people building on an agentic project. It might be 3 or 4, so tiny teams. But nonetheless, it does kind of need to be more than one person. And so the sort of way to solve for this in my head is stories scaled out across multiple contributors working in parallel. But those stories are then decomposed into tasks associated with that individual contributor's specialization. So if we have a team of, let's say, a front-end engineer, a back-end engineer, and a DevOps engineer, in the process of decomposing that backlog, each of the stories is going to target one unique area of the architecture, be it front-end, back-end, or DevOps, rather than trying to span the whole code base as it builds. Most of the tools right now tend to assume the role of a full-stack developer that can just do everything. And I think as we transition more into these specialized roles, we're going to somewhat naturally solve for that problem of being able to collaborate on work. And so what that will give us is a backlog of tasks that very nicely map to areas of a code base that are less likely to cause merge conflicts and things to work to butt up against one another. And it'll allow us to scale to multiple contributors working in parallel. So rather than having to work in series, that's kind of the big change that we see needed in our own framework of how we build things spec-driven, is that ability to go parallel. With that comes some challenges. So if we have multiple individual contributors working in parallel on tasks, all of a sudden, if one of them forgets to commit during the course of their work, the consequences of that are now much greater, because the code base in the background is moving along not at the pace of regular work, but at the pace of an agentic team. So the pace of change in the code base, if somebody forgets to commit, rebase, pull the latest, is far, far greater. So we actually need this staging gate within our development lifecycle that actually prevents anybody from moving on without committing, pushing, and making sure that everything is rebased with master. Last but not least, that backlog, being able to synchronize it with a sort of an agile management tool like a Jira or a GitHub Issues or a Linear to give greater transparency into the work of those agents via MCP connectivity. Makes the whole thing just scale up across a broader team much, much better. A couple of lessons along the way that we've had on some real projects. So definitely found spec-driven as a methodology fantastic for MVP. And I mean true minimum viable product, not prototypes, but true MVPs that you're going to put in the hands of a stakeholder, that you're actually going to ship as product and get in customers' hands. I think it's a fantastic build methodology for that. And to that end, really, really good on greenfield projects. I've struggled to date with large brownfield projects. Some of the tooling we use has a workflow for ingesting and building specs that would allow models to do great things on brownfield projects. But to date, like early experiments, not the best. I've no doubt that that's something that we'll see substantial progress in over the next couple of months. pretty good as well in modernization. So like being able to upgrade, let's say we're stuck on, I don't know, Node 10 and we want to upgrade to Node 22. That's the type of work that's sort of toil for a developer. Great example of having a bunch of agents go after that task. We've also found it really useful, and this is an unusual one, but projects that have a challenging business case. So where it's kind of tough to stack up the case for investment, and let's say it takes a team of 5-6 months to build something. That's not something a business is willing to commit to. If we're able to accelerate those timelines and cut them in half, or even a quarter, that makes for a much more viable business case, provided that they're willing to accept that this is a very progressive way of building software, and it does not come without its risks. But with that caveat, plenty of businesses are willing to take on a more otherwise challenging thing to go after using spec-driven. So it's just been like a nice way of reframing how we think about building software as well. I mentioned, to date we've struggled in brownfield, struggled in proprietary or legacy languages. Things that the model isn't very good at, although we have some plans to work with the folks in Tesla to try and help with exactly that. And also actually not great for simple prototypes. So if you just want a front-end prototype, the spec-driven workflow is actually quite a heavyweight thing for building that really simple prototype. So probably better off to use some sort of vibe coding tool, be it Kiro in vibe mode or a bolt.new or whatever. Just out of curiosity, by show of hands, how many folks here have used a spec-driven IDE in the last month? Okay, more than half. Okay, so I'm not completely preaching to the converted here, but many of you already have experience. If you haven't yet used some sort of spec-driven enabled IDE, there's two tools in particular that I've really liked of late. The first is probably Kiro, is a great place to start. If you've got a couple of hours to spare in building something with a spec-driven methodology, and you want to move relatively quickly, its user interface makes it a really, really easy on-ramp, and it's a great place to get started. If you feel like you've got a couple of days to devote, and you really want to go deep on this stuff and see what maybe a little preview of the future might look like, the BMAD method, which is an open source project on GitHub that installs quite nicely into the likes of Claude Code or Cursor, is a fantastic place to start. It does a lot of that specialized role definition, and allows you to follow a really detailed workflow for your spec-driven methodology. And then a little bit on what the future might hold here. So I sort of reckon the hyperparameter race might not be the path to success here now. And what we're going to see over the next 6 to 12 months is probably going to be more of a refinement of the techniques and ways that we interact with foundation models. That's what I'm hopeful for. I've certainly been wrong in the past, but that feels like the direction of travel right now. I have great faith in the fact that the best approximation of what spec-driven development is going to look like in the future right now is living in the open source. I think that's frickin' awesome, in the form of BMAD. And I'm really excited as well to see this get codified into Kiro back in, was it June, July, as the first thing to codify some of these spec-driven primitives. And even this week, like 2 days ago, Google launching anti-gravity. Again, a couple of spec-driven things showing up in anti-gravity as well. So I'm really excited to see what some of the other tool vendors do, like what's going to come next as we try to codify some of these techniques into how we build. If you're looking to take some of this further, a couple of resources. Brigitte Bockler has some fantastic writing on Martin Fowler's blog on evaluating both the kind of methodology of spec-driven and then also some of the tools. Well worth checking out some of her writing. And then we mentioned, Kiro is a great place to get started if you've got a couple of hours to spare. And if you want to go really, really deep, I would recommend the BMAD method. It's out there on GitHub. You can install it into your IDE and have a play around. I don't know how we're doing on time for questions. Nope. I think we're done. All right. I will be around if people want to chat, and thank you so much for having me.